Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is going to be the second video in using Python for data. And this we're going to do is going to be using Pyarrow and Pandas, or at least introducing these libraries. A lot of this isn't going to be necessarily deep dives in these libraries, but just knowing sort of like what they are, how the basics of how you use them, and where they fit in the mix, and then you can do deeper exploration from there. Like that's kind of the point of this video series. But to understand sort of the next thing I want to talk about, which is Python, which is technically Apache Arrow, you need to understand sort of like data structures a little bit, or just like how we would structure table data. Okay, and again, when I think of a table, there's columns and rows. So for example, here's a row, which is our title row. So we maybe have every record has an ID, we have a name, and then maybe there's an age, and maybe an email. Okay, so that would be like one row. That'd be the title row, and then let's say we have a couple of records. So we have like one Bob who is 32, and his email is bob@bob.com. Okay, and then there's, I'll do two more records. Okay, so this is generally how like table data is kind of presented. So Bob, again, we'll just make this Stacy and John, and then we'll just pretend their emails are changed. I'll just give them slightly different ages, 20, 40. Okay, so basically this is your data. So you would imagine seeing this like on a spreadsheet or something like that. Now, generally when you're working with a database, like directly with like a transactional database, when you're working with like me, again, I mainly have worked with web applications, you generally deal with the data in rows. So essentially the way the data is kind of organized, because, you know, if I'm saying, hey, I'm adding this data, so each of these data is like a row. So let me just put this all the way in the back. So send to the back. Oh, Control Z. This would be a different row of data, and then this would be a different row of data. Okay. And this works fine when you're adding and subtracting data. So for example, because if I want to add data, technically what I'm doing is I'm adding a new row. So thinking of this as a list of rows, and I'm adding a new piece of data, and I'm inserting data as a new row at the bottom, makes a lot of sense of how you're going to structure your data. But when I want to analyze the data, having my data in rows can be maybe not quite as friendly. So let me just do this. Okay, and let's just not select those. Just give this a little bit more space. There we go. Okay, so doing it in this sort of like row-wise, good for like necessarily, again, writes per se, because I can just, again, add the additional row at the end of the list of items. Just smack it there at the end. But what if I want to like do a search? I want to say, hey, get me all the things, all the people who have an age over 30. Okay, so what would happen is that I would have to loop through each of these rows one by one, and then go through, and then generally like the data in the row is another array. It's not like a key value pair type situation. So essentially it has to like loop through the array and see that the item at the right index, and then evaluate the value. So essentially it's taking longer because it's going first row, then it's moving 1, 2, 3, and then evaluating this number. Then it finishes the iteration cycle. Then it goes to the next row and does the same thing over and over again. So the amount of work, and on top of it, the amount of data you have to have in your memory, because now actually I have to have this whole row in my computer memory. Okay, so I have to maintain the whole row when really the only thing I want to look at is age. The only thing I'm evaluating is age. Okay, so because of that, having your data organized in a row format, which is again very intuitive, you know, from just normal human brain think, but not necessarily ideal for data. So what Python Arrow and Pandas does is that instead of organizing the data into rows, okay, what's going to happen is that each of these are going to be a column. So instead of having an array of rows, you have an array of columns. Okay, let me just send this all the way to the back. Again, send to the back. Okay. There we go. So now we have the data in these columns. And now here's the beauty of it. If I want to go like filter by age, and I would say, hey, give me all the 8 ones that have an age over 20, the only thing that really needs to be currently loaded in my computer's memory is this column right here. Okay, because that's the only thing I need to look at. And I'm only looping through this. I'm not looping through several rows. I'm just going to loop through these numbers, keep track of which indexes, because again, all of these should mirror each other. So let's say this is index 0, because it's the first item in the array. If I know that matches my query, then I know when I look through the other columns, the matching data is whatever's in index 0. So this index 0 in this array, this array, this array, this array. But the actual query, the actual ability for me to scan the data is going to be a lot quicker. Okay, because I only need to look through this. So this gets loaded up. So only this column can get loaded up into memory, and you're using a lot less memory. You're looking through a much more succinct data structure. So it's going to be a lot faster. And again, when we're thinking about like larger data sets, okay, that's generally where like data analysis is going to come in. We're not talking about 10, 20, 30 records. We're talking about maybe thousands, hundreds of thousands, millions of records, hundreds of megs, gigs, terabytes, petabytes of data. Okay, anything you can do to change it from taking 3 days to do a query to a couple of hours, because again, when you're querying large data sets, it's going to take some time. Really matters. So this is where like data structures really start having a practical, quite a practical and profound difference in your day-to-day life. And again, if you're like that developer, that data analyst, data scientist, you're not necessarily delving into sort of like how the data is structured. That's what the people who create, Arrow and Pandas, they think about, because they're creating these libraries to make your life easier. But just so you can understand why it's making your life easier and why these libraries matter. And because these libraries exist, it's part of it. And then again, there's equivalent in other, but the Python ones and plus everything else that Python just kind of brings to the table has made Python sort of a very nice home for doing this kind of work. Okay, so now you understand what's the difference between sort of row-based formatting versus columnar formatting and columnar data. And the reason why that matters is because that's what Arrow is. Arrow is a specification for how to structure data into columns, particularly in memory. So the idea is that it's not necessarily dealing with how to do it as a file. That's going to be something called Parquet. Parquet deals with having a columnar file format. Okay, and I'll mention that later on in the video. And then Pandas data frames are technically a columnar format, but the Arrow format is actually even one that's even more optimized, more smooth. Okay, really built to take advantage of maximizing your memory and being able to use memory most efficiently as possible, and basically create this intermediate format that if other formats, if different libraries and different tools implement Arrow, switching between different like formats becomes a lot easier. Okay, and you'll see that's going to be one of the big benefits of using Arrow with Pandas in a second. But the cool thing about Arrow is like Pandas is really just like a Python library. So like Pandas again has that cool columnar format, the data frame, but with Apache Arrow, you can have there's libraries to be using the Arrow format pretty much in every language that's mainly used today. Did I see Go in that list? Yeah, there's Go. Okay, so Arrow, an understanding of the Arrow format and how to work with data using Arrow can then translate to you in other languages, which is really nice. Okay, but we're going to be focusing on Pyarrow, the Python implementation for Arrow. Cool. And what's going to happen here is first thing we want to do, and then Pandas, again, a library for handling data. So the idea is like Pandas, the big thing is it organizes your data in a columnar format using NumPy arrays. So essentially what Pandas does, the Pandas data frame, is essentially that type of format. Again, and I think nowadays it might be using a little bit more arrow under the hood too, to optimize it more. But the idea is that it takes the NumPy arrays because of their speed, because you could theoretically replicate this using Python lists and use Python lists for each column. But again, Python lists are slower than NumPy arrays. So by using NumPy arrays, the Pandas data frame allows you to have that columnar structure and get all the benefits of working with columns in that column way of structuring your data using NumPy arrays. So just kind of seeing like how this stuff sort of connects and relates to each other. So, and then again, Pandas has many functions for you to interact with that data sort of in that data frame. So when you have that structure, how can I query the data, search through the data, grab parts of the data? Pandas has all these functions for you to do that with. Okay. So what we're going to focus on today is basically loading these libraries. We're going to use Pyarrow to load files, because basically loading files via arrow and using arrow as an intermediate format is actually faster than loading the file directly with Pandas. Okay. Again, it won't be noticeable with small data sets we're using today, but again, imagine larger 100 meg, gigabyte, multiple terabyte, petabyte data sets. You know, being able to load it faster is going to definitely be to your benefit. So what you do is you load it into Pyarrow, because Pyarrow can load a file into the arrow format quickly. And since arrow is a columnar format from the get-go, converting one columnar format to another columnar format is actually fairly quick. So basically, you go from your file source to arrow, and then arrow gets converted into a Pandas data frame, which happens very quick, versus what's going on under the hood in Pandas, which I'm not too familiar with exactly how Pandas is loading the file, like how it implements it, but it takes longer. That's, I guess, the bottom line. Okay, cool. So we got that. So what I'm going to do is I'm going to head back to our Visual Studio Code, and I'm going to I'm back in my notebooks folder that we created in the first video, and I'm going to run Jupyter Lab. So okay, the server's running. Okay, and see, there's our first notebook that we created in the last video, so we'll just use that still. But I'm going to include a couple other libraries. So I also want to include Pyarrow, and I want to include Pandas. Okay, and again, by including them, using the pip install at the top of the notebook, if I give this notebook to somebody else and they don't have those libraries installed, this will just make sure that they are. So I just hit play, just recess that. Now it's downloading all those libraries and taking care of that. And there it goes. It's been installed. Cool. Okay, and then I'm going to want to import these libraries. So I'm going to want to generally you're going to want to import Pandas as PD. So PD short for Pandas. And you're going to want to import Pyarrow as PA. Okay, and we'll reevaluate that. Cool. Again, basically you just hit the play button whenever you need to reevaluate a particular cell. Now what we're going to want is we're going to want some data to kind of bring in here. Okay, so I'll show you a couple different data formats. Okay, so again, in our notebooks folder, last time I created this sources folder. So what I'm going to first do is we'll create a CSV file. So we're going to say, you know, data.csv. And CSV stands for comma separated values. The comma is what's called your delimiter. It's the thing that separates the different values. So for example, again, if I want to create that same set of data that we just saw a second ago in a CSV, it would look like this. It would be like ID, name, age, ID, name, age. We'll just do ID, name, age. Okay, and so then the next line. So the next line would be then one John 42. Actually, no, I made it a space separated values. Okay, 1 John 42. 2 Steve 32. 3 Stacy 20. Okay, so there we have a comma separated value. So each line represents one row, and then the values of that row are separated by commas. And the thing is that there's you always want to take a look at the data, because sometimes you'll see CSV files that actually use other delimiters. They might be using a semicolon, they might be using tabs, spaces, sometimes just other really random delimiters like a pipe. So a pipe is like this character right there. Okay, so do always check your CSV files to make sure that they actually are comma separated, because it's not always the case. Okay, so cool, we have this file. So let's go head over to the Pyarrow documentation. Let's see here, reading and writing CSV files. So what we're going to want to do is we're going to want to import from Pyarrow the CSV function. So let's do that. Well, I already have PD, so we can use just pd.csv. And basically to read the file, we would use this read CSV function, and that's going to create a Pyarrow table. So Pyarrow table is like the equivalent of like a Pandas data frame, but again, the Pyarrow format is just like this sleeker open source format. It's really cool. So table read CSV. So let's just do that. Let me go back to the notebook. Here's the notebook. So what I would do is I would say, okay, CSV table, we'll just call it that, equals PA for Pyarrow, because again we imported this Pyarrow back up here. Okay, PA dot CSV dot CSV. Let's see here, was it read CSV? I think it was. Back to the docs here. Read CSV. Yep. Read. I keep going to the wrong place. Read CSV. And then we're going to pass in the file. Now again, it's going to be based on where you're at, which is a notebook folder. So I want to go inside that data sources folder. So let me just make sure that I'm looking at this correctly, which is going to be sources. So I want to type in like sources / data.csv. Okay, so that should be correct. And then we want to print it just to make sure that we got what we thought we got, CSV table. And yeah, so let's see here. Let's run that line. Module Pyarrow has no attribute CSV. Let's see here. Let me go take a look at the docs. Did I write that wrong? From Pyarrow import CSV. Let's just do it that way. Okay. So I will go back to my imports. I'm going to say from Pyarrow import CSV. And then I'm going to do that. And then I'm going to want to reevaluate this. And then let's reevaluate this. And that worked. And see, there it is. Okay, so we can see see how each column is its own sort of row. So we have the names, John, Stephen, Stacy, age, 42, 32, 20, ID 1, 2, and 3. Okay, and see it has the types, tracks the schema, and that's the cool thing. It infers the schema into 64, so it realizes that, hey, like this is going to be a 64-bit integer, or at least that's what it inferred. This is going to be a string, even though technically a CSV is just text. So that's pretty cool. Now, with Pyarrow, I can then just also then go convert it to other file formats, because when you're talking about huge data sets, if I'm doing like an ETL job, again, taking one data from source and turning it to somewhere else, I don't necessarily want it in CSV or JSON format. I'm going to probably want it in what's called Parquet format. So in the same way that Arrow organizes data in columns while you're reading it, while you're using it in your computer, while you're processing it, so in memory, Parquet allows you to store the data as a file that's organized in that columnar format. And the benefit of that is, if you're loading a file that's in a columnar format to an in-memory representation that is a columnar format, that's going to be like the fastest load times, and you get all the benefits of the analysis benefits of having it in a columnar format. So generally, you're going to have maybe CSVs or data from a database or JSON files that you're going to want to then turn into Parquet files that then, again, the data analysts, data scientists can read And if you're a data analyst and data scientist, maybe your data engineer is already making these conversions for you. Okay, but if I wanted to do that, if I wanted to go then and save this as a Parquet file, I would just go from Pyarrow, import or actually it's from, I think it's import Pyarrow dot Parquet. I think I spelled that wrong. Nope, I got it. Parquet as PQ. Okay, so PQ would be like just how we do Parquet stuff. Okay, and then we'll leave that cell like that. And then what I can do is I can take the CSV table, and let's see how we write it. So back to the documentation for Pyarrow. And we're going to say, hey, we want to use Pyarrow for Parquet files. Reading JSON formats, here we go, reading and writing Apache Parquet. Okay. So I want to write, so we would just write the table. That means you write it as a file. Okay. I want to see the right example. Okay. Actually, let me just go right here in the table contents. That'll be faster. Writing, Parquet file, writing options. Here we go. Okay, write table has a number, version, data page size, flavor. But show me an example. Because here I got that. You read it. Data needs to be decoded from Parquet format to compression. It can't be easily mapped from disk. Map option, PQ arrow, read table. We got that. Show me where, example, write table, where, string, Pyarrow. Okay. I think it's just going to be simple as this. For just a basic write. So essentially what we would do is we're going to say bq.write table. I need to specify source. So let's see here. The table. So there's the table that we need to, and then where is going to be where we save it. Okay. So let's go back over here. So the table should equal CSV table. And the where should equal, we're going to say sources dot CSV data dot Parquet. Okay, now let's see if that works. So let's run that. And let's just see if that file got created. And there it is, csv.parquet. Okay, cool. Now let's see that it actually encode the data correctly. So let's open it up. So what I'm going to do is I'm going to say, PQ table equals PQ.read table. And I'm just going to say sources / CSV data.parquet. Okay, so that's the file. And then I want to, like that. Let's see why. File system path selector. PQ.read table. Threads. Actually, wait, did I put the right file name? Sources, that's why. Sources, let's try that again. Yep, so there it worked. And then I can be like print PQ table. And there it is. Okay, so basically I can go grab that file from the Parquet file. I can go grab that data from the CSV file. Okay, so, and I can go write it to another format. So that's pretty cool. You can do JSON format. The only thing about JSON format is you have to do it in a very particular way. So here I'll create like a data.json. It has to be line separated rows. So essentially if we were to do that same data that we just did a second ago in JSON for the purposes, okay, and let me just actually take a look at data CSV here. I'm going to put this over here and we'll just convert it one by one. Okay, what I would do is you wouldn't have this header row. Instead, each of these would be essentially a JSON object. So this would be ID This would be name, and that's a string. And then this would be age. Okay, and then basically we would create 2 more of these. And then I would make this like do Steve 32 3 Stacy 20. Okay, and see, it's your IDEs might complain because generally like JSON files aren't set up this way where it's multiple JSON objects on top of each other. And if it would be like an array of JSON objects, but this is the way like Arrow's gonna want it if you want to import JSON files. So let's just show you that, and then we'll move on to pandas. Cool. So then we're gonna go over here to reading JSON files. Okay, and usage. So we'll import from Pyarrow, import JSON. So let's add that in there, and then the function is going to be JSON read JSON. Simple enough. Okay. So from Pyarrow, import import JSON. Okay, and then JSON.read JSON sources/data.json. Let me just make sure that's what I called it. Data.json, yep. And then we want to save that into like, we'll call it table2 equals JSON. And then let's print to the table table2. And then let's just evaluate that. And yep, see, I get the data. Okay. So for the purposes of these early stages, really you want to use Pyarrow to pull the data. The idea is that we got Pyarrow here so we can pull and write data very, very quickly. Okay. But once we pull the data, we have it as a Pyarrow table. But we're going to want to use all of Pandas really cool analytical like tools and functions and fun stuff. So we're going to want to convert it to Pandas. So we can easily do that, okay, because basically it has a toPandas function. So it has toPandas and from pandas, okay. And that allows you to either take a data frame that's in a pandas data frame and turn it to a Pyarrow table. So in case, let's say, hey, you do all your changes and now you want to go use Arrow to put it back into a Parquet file or to a JSON file, even though Pandas can do that. So if you're working with small data sets, you could just do it in Pandas and you don't necessarily need Arrow. But if you're working with large data sets, you can speed up your read and write times using Arrow. And then you could do a lot of analytical work just straight out of Arrow. And if you're working outside of Python, using Arrow might just be the way to go. Cool. So now going forward, let's do that. Let's see here. Let's go back to the notebook. And basically what we want to do is so we'll just say, hey, our pandas table equals, then I think we already have it imported as PA, right? Yep, PA. Okay. So now I can be like pandas table and just say PA dot toPandas. And the thing we want to convert to pandas is table2, that thing we just got from the JSON. And then what we'll do is we'll print the pandas table to confirm that it is a pandas data frame. Okay, module Pyarrow has no attribute to pandas. Let's go back over here. Oh, dot table. Oh, no, here we go. Table.toPandas. Ah, I did that wrong. Okay, so it's a method on the actual table format. So in that case, what I would do here, so instead of, I just do this, table2 dot toPandas. I want to say take that and turn that to pandas. Let's reevaluate that. And there's it, and see now it's a pandas table, and so you can see it looks like a pandas data frame, which makes it look like in that nice format, because that's how pandas prints out its data frames. You print them. Cool. And now I can start actually using like Pandas functions. So let's start taking a look at the Pandas documentation to see some of the cool things you can do. Okay, and there's a lot. Okay, so how can you read tabular data, subset, how to create plots and data, how to create columns, derive, reshape. Let's just see if we can find like a quick sort of like query. How can I reshape out the layer variables, calculate summary statistic. Let's do that. Okay. User guide. So let's see if we can just calculate like we aggregate their ages. Okay. Group by sorting. So let's see here, aggregation. That's what I want to do. Okay. Once the group by object has been created, several methods are able to do. Okay, so I guess we do have to group by first. Okay. So let's see here, get group bar. Well, that's selecting a group versus create a group. So group, splitting an object into groups. Group by class. So the idea there is you would group them by, well, I don't need to necessarily group them. So let's see here. Apply multiple functions once. Okay, and then where is the actual aggregation function? Here we go. Yep, here we go. Aggregate and then np.sum. Aggregate only ag method, or equivocally the ag method. Once group by object has been created, several methods are available to perform computation on the group data. These options are similar to aggregating API. So yeah, so the idea here is what you would do first is that let's say you had data, and in this case, let's say I had more data and I had people with like the same age. I might group people with the same age or the same name and then add them together, but I don't really have anything good to group them by, so that's not necessarily going to work out for this example. 10 minutes of pandas, computational tools. So you can see there's a lot of cool things you can do. Okay, it's just a matter of finding sort of like the thing you need to do at that moment. Nullable integer data, table visualizations. Ooh, let's take a look at that. Styler object. Okay, so you can create nice little visualization straight out of pandas. Okay, but let's just see here. Would we want to do that? df.style. So let's try that out. So df means data frame. So in that case, for me, my data frame is pandas table. So dot style. Let's see how that looks. That do a thing? It's not callable. Oh, okay, it's not. Let's do that. And see, now that looks a lot nicer than this. Okay, so that's a cool thing you can do. Okay, but you can see here, like pandas has a lot going on. Okay, well, we'll go a little bit deeper and have more focused examples in later videos. But the idea here is like, now you're trying to kind of get the picture. Like I would spin up a notebook. I can pull my data. I can use Arrow to pull that data in from some source. Okay, then I can take that, convert it to a pandas data frame, do all my manipulations, whatever I want to do, create aggregations, whatnot, then convert it back into a Pyarrow table, save it into a Parquet file, or do it directly from pandas depending on the size of your data set. And again, you could also use Pyarrow to do a lot of calculations. Okay, it has its own ways of computing and its own methods for doing computation. So you can see like all these different methods it has for like finding the mean, the max, mode. They're all like listed here. Okay, I don't know how comparable the variety you have here is, but it looks like there's quite a bit you can use as far as analyzing your Arrow data sets. So both of these libraries, you can turn your data into a Pyarrow table or a pandas data frame and take advantage of that library's analytical tools. And then when you're done, save it into the format that you need. So again, if you're the data engineer, save it into the format you need, so that way the data analyst can then go create the BI tables, or the data scientist can go create like the learning tools. Okay. Yeah. So hopefully you guys enjoyed that. My name is Alex Merced from alexmercedcode.com. Again, this is a tour of different sort of data related libraries in Python. I am not a data scientist. I am not a data analyst. I am not a data scientist. or data engineer. But it's something I'm learning more about. It's something I figured I would bring you guys on the journey with me as I learn more about it, so that way I can bring my unique sort of previously web developer experience and framing, and hopefully make this more palpable and easier to kind of get started, because you get the big picture, and then it's just a matter of just learning the details and learning how to apply different tools that are within these libraries. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.